Hi and welcome. My name is Ricky and I will be taking you through this Introduction to Programming course. So this Introduction to Programming course is a course about common concepts about programming. So you'll find that most programming languages, they just have the same concepts and the same syntax, and that is what this course is about. So if you have never attended a CS class, that is a computer science class, this is a good course for you to have a look at and see some of the things that you'll encounter in most programming languages. So we'll look at different things, and even though during the course I will be doing a little bit of code illustrations here and there, that will only be to prove some particular point or just as an illustration for better understanding of that particular point. It is important for you to know that this Introduction to Programming course is not going to make you an expert in any particular programming language, and any programming language that I use for illustration will be because of ease of access. That is because of how fast I can get something running in it, or how easy it is for something to be illustrated in it. So that will be the only reason for which I will use any particular programming language, and it will not be because I'm inclined towards them, and it will not be a way for me to try to push you towards any programming language. So this is about concepts, and it is not about a particular programming language. And once you're done with this course, it will be much easier for you to go out and pick any programming language and just learn it. And as you learn those programming languages, you'll realize that everything that was covered in this course will somehow be in that particular programming language. And that is what this course is about. So let's get started. You just join and take the ride. I will see you in the next videos. Hi and welcome to this course by bizanosa.com. So in this Introduction to Programming course, we're going to learn some principles, concepts, and basically things that are related to programming. So as you know, most programming languages actually have the same principles, the same concepts, the same constructs and behavior patterns. So this particular course is not going to be teaching you any one particular programming. So it's very important to me that you understand that this course is not going to be making you an expert in any particular programming language. Even though at some point I will be using some programming language to illustrate particular points, that will just be for illustration purposes, because in the end it is you who will decide the programming language that you want to learn, and this Introduction to Programming will give you a good foundation that will enable you to go out and learn any programming language, because most of them, as I've said, they just have the same concepts, the same principles, just the same things. So if you can go through this Introduction to Programming and understand every concept as well as it should be, then going out and understanding other programming languages won't be difficult. So the course will not teach you any programming language in particular. Most of it will be theory and a bit of illustration about things that I do believe are best understood when illustrated. So the objective of this Introduction to Programming course is just to show you the concepts that are most common in nearly every programming language, and that will enable you to go out and learn any language that you prefer. So are there any tools that you're going to need to install? Not really, because if I have to demonstrate some code here and there, I will use. So in some cases, I will be using C++ to demonstrate some code, and I will use the C++ shell. So this should not alert you and should not worry you, because you don't have to follow along. But if you want to follow along, you'll just go to cpp.sh and you'll type everything as I write it out, and that will put a good foundation for you. And also I will be doing some illustrations here and there in JavaScript. So with JavaScript I will use Scratchpad. So Scratchpad is an inbuilt tool. Scratchpad is an inbuilt tool in Firefox. So you'll just press Shift F4 on your computer and Scratchpad shows up. So if you want to follow along with me, you don't really have to install anything. So I'll see you in the next video where we're going to look at a bit of some code just to see how code actually looks like. So I'll see you in that video. So what is programming? Programming is just giving directions and instructions to a computer system to tell the computer what to do. So you as a programmer, you'd write some code, you'd write your statements, your lines of code, and this code will be expected to tell the computer system what to do. So let's have a look at some samples of code and just see what a minimalistic code can look like. So here we have the same code. This all does the same thing. This is a simple piece of code that just adds 2 plus 2 minus 2 and then outputs the result for us. So this is how it is in C++. This is how it is in Java. And this is how it is in JavaScript. Most of the times it's actually true that you can do the same thing in any programming languages. So you can do the same thing in different programming languages. But of course the implementations would be different and probably where they will be running will also be different. So the purpose of this video is just to show you some sample code. So what I want to do, I want to take this code and at least run it just to show you the output here and the output for this. So I will only run the C++ and the JavaScript code. So I want to copy that code from here, and what I'm using here is dev C++. So you don't have to worry about this because I'm just here to copy this code. But if you want to use this dev C++ and investigate about it, just go online and search for dev C++. So if I come back to here, paste the entire thing there, and then I run it, you'll see it gives us an output of 2 down here. So that's in C++. So if you want to follow along with this, you can just copy this, and if you see this result, feel happy. Now let's go and do the JavaScript part. So as I said, this is just for demonstration purposes. You don't have to follow along. Now in JavaScript, I just want to do an alert. And what an alert is, this one, have you ever seen pop-ups on websites? This is actually the basic building block. So this one will just alert the result for us. It will show a pop-up. So if I run this, we'll see it gives us the same thing. So that's all I wanted to do in this video, just to show you that the same thing can be done in different programming languages, but you'd have to do different implementations based on that particular programming language. For example, if you want to build Twitter, you can build your own Twitter in PHP. You can build your own Twitter in Python. You can build your own Twitter right now even in Node.js. There is no one programming language that does everything and that can only be used for one particular thing. You can find a way to implement different things in different programming languages. That was the absolute objective of this video. So I'll see you in the next video. Hi and welcome back. So programming languages can be put into high-level or low-level programming languages. Actually, most of the programming languages that we use nowadays are just high-level programming languages, and most of the ones you'll be using will definitely be high-level, except for some very old languages that are used for doing very specific things. So a high-level programming language, this one just offers some abstraction from the complexities of the computer. So what that means is that as a programmer, you don't really have to worry how things are going to be handled way down in the computer system. So this programming language, the high-level programming language, will protect you from those kinds of details. You don't really have to know. You don't have to know how memory is going to be allocated in the computer. You don't have to know how the motherboard is going to handle things. Your job is just to use this programming language as the interface, and this programming language, through its compiler or through its interpreter, will be the one to communicate these things to the system. So in most cases, the high-level programming language will just use natural language. That's why you find that you have things like if, else, if something happens, do this. So this is just something, if someone sees this, they know exactly what an if is. That basically means if this one is true, do something here. And then you can also hear about things like while. So you see, it uses just natural language. Most programming languages, you'll find these are there. We'll have a look at these ones later on, and you will understand them then. But right now, just know that high-level programming languages, they just use natural language. They don't really interface with the actual computer system. They don't give direct instructions. You as a programmer, you're not required to give direct instructions. So the most important word to note about here is abstraction. So it will abstract you from the complex system. It just helps you use the programming language and interact with the computer system without really worrying how the underlyings of the computer works. So that's a high-level programming language. And then we also have the low-level ones. These ones, they give little or no abstraction from a computer's instruction set architecture. So the ISA in a computer, the instruction set architecture, this is a part of the computer that handles the programmatic things of a computer. For example, if you install something and you try to access it, it is that part of the computer that will handle this. If you plug in a device into your computer, it is this part, the ISA, that will know what to do. So the instruction set architecture just looks at the function that needs to be done and then provides instructions to the motherboard, to the computer system. So a low-level language will allow you to directly interact with the underlyings of the computer. The best way to think of a low-level programming language is it lets you communicate with the computer hardware. So you'll give instructions and commands using machine language. So machine language, this is language that the motherboard understands. This is language that the computer system understands. So if you say put something into maybe a certain memory, there's a way the computer will just understand this directly and will know what to do. So if you have to do things like allocating memory in a low-level language, it will be up to you to tell the computer how to do that. Unlike in high level, you will just do your part, and things like allocating memories will be done by the programming language itself. So if you want to read more about this high level and low level, you can go and read about them in this link on Wikipedia. So for me, I'm not trying to do an academic kind of thing in this introduction to programming. I want anyone, whether you're in a CS class, that's computer science class, or a related course, or you're just someone who just wants to learn programming. My intention is not the academic side. I just want to show you the bits and pieces that you will encounter in any programming language. And those are the things we're going to be dealing with. So I'll see you in the next video. Hi, and welcome back. So based on how a program is run, we can say a programming language can be compiled or interpreted. So you can go ahead and read more about this compiled language here on Wikipedia, and the interpreted language, you can also read more about it on Wikipedia in this link. There is a lot more information about these things there, especially if you're interested in the academic side. You should go ahead and check out these links. So a compiled language, this is a language that it has to be converted to machine code before it is run. Basically what this means is when you write this code, you cannot just take it directly and run it. You have to convert it into something first and then run it. So if it is a Windows application, you'll convert it into maybe a .exe executable file. If it is Java, you'll compile it into something that can run in the Java virtual environment. So the tool that does the job of compilation is called a compiler. So as I've said, you can read more about all this in the Wikipedia pages, and then we have interpreted. So in a moment, I will come to an illustration of these two in a way that you can understand it way better. So an interpreted language. So examples here, going back to compile, you can say something like C++, and most .NET applications. Those are compiled languages because you have to compile them first before you can run them. Java, to some extent, is compiled, although it is compiled into bytecode, which will still be run in the Java virtual machine, the JVM. So an interpreted language, this is a language that you just write and run. So a very good example here is JavaScript. You'll write JavaScript, and then you don't have to do anything to the JavaScript code. You will just take it to a browser and run it, or whichever machine you want to run the JavaScript on. So that's a good example. JavaScript, you just run it. Then there, Python is also interpreted, and then we have PHP also interpreted. You just write the code. You don't have to compile it. You just take it to the PHP application on the server, and this will run. So an interpreter is what is used to interpret them. Different programming languages, of course, have different interpreters. So in the next video, I want to do an illustration of what these are using an analogy. So I'll see you in the next video where we're going to look at this compiled and interpreted in an analogous kind of way. See you then. Hi and welcome back. So in the last video we saw something about compiled and interpreted languages, and in this video I want to do analogy of the two. So if I come here and I say this is a compiled language, first of all you have the source code, and then it has to go through a compiler, and then it has to come out as the code that will be run. So let me think in terms of a sugarcane. So let's say you have sugarcane and you want to sweeten your tea or coffee in a compiled kind of setting. In a compiled kind of setting, you'll have to take the sugar to the factory, right? You'll take it to the factory, and then it will bring back our application, which is refined sugar. And then you can take the sugar and put it in your cup of coffee. So in this case, the sugarcane is our source code. The sugarcane is our source code, and this is our compiler. And this is our compiled code, right? So in this case, you saw that you had to take the sugar to be refined before you could use it. So in the next example, let's look at interpreted using the same analogy of the sugar and our tea. Okay, now in an interpreted system, we still have our sugar, right? We still have our sugar cane. And then the idea or the goal is that we want to get our coffee or our tea sweetened. So in an interpreted system, you'll take this sugar cane. Let's say in here you have some kind of a machine, or some kind of a lever that you can use to squeeze out the sugar cane, just right there. And then you will use that to sweeten your tea or coffee directly. So you'll see here we don't have to compile it. We just take our sugar, we come and crush it and get the tea. So this is our end result, what the user will see. This is our source code. And this right here, this is our interpreter. So I hope you've understood the difference between these two. And if not, you can go and read more on them in these Wikipedia links. So using the sugar analogy, you can see in a compiled system, this has to be refined. In an interpreted system, this one will just be run. The source code will be read directly and the information extracted from it. So I'll see you in the next video. Hi there. Let's look at data types. So what are data types? In different programming languages, data is handled differently. So let me start by giving an example. Let's say you're creating a system, and in this system you expected to handle student details. So a student will have a name, they might have an identity, a national identity number, and then there may be a field where they need to say whether something is true or false, like married, yes or no. And then there may be something like date of birth. So these are different data types and they would need to be handled differently. We have programming languages which are strongly typed, and then we have those which are weakly typed. So a strongly typed programming language is one which explicitly requires you to say the kind of data that is expected at any particular point. Like if you create a variable, we're going to look at variables later on, but if you create a variable, you have to say what kind of data type that variable will be. Is it going to be a number? Is it going to be some kind of unexpected sentence? Is it going to be a character? You have to say that in a strongly typed language. A weakly typed language, you just define the variable and you can give it any data type when you're implementing it. So if you've ever used Access, Microsoft Access, when creating some kind of a database, you'll also see there are different data types there. You'll come across something like currency. I think there's currency, there's a date, there's text. So that's the same kind of thing, data type. So they vary with programming languages. And as I said, this introduction to programming is not is not an academic course. So I'm telling you things that you're going to experience in programming languages. So you will use one programming language, you find that it doesn't have something that another has. An example is SQL. If you look at the kind of data that you can put in SQL, you'll have different things as compared to something you'll have in Java. So going back to what is a data type. So data types provide identification for various types of data used in computer systems. So if you're putting in some kind of data into the system, you need to tell it the kind of data you're putting in. Is it a number? Is it a character? If you want to look at the various data types and a whole lot more information about this, just go to these two links. But generally, in most programming languages, you're going to come across some kind of data that handles characters. So a character, something like A, B, or something that handles words, maybe name. And then you also you'll have some kind of a data type that handles numbers. So you can have an integer 1, 2, or -1, -2, or you can have a floating point number, which essentially deals with decimals. So if you have 2.1, 3.14, so there'll be some kind of data type that will handle that particular kind of data in the programming language. So it will all entirely depend on the kinds of data types that are available in that particular programming language that you will be using. And of course, when you're learning the programming language, you'll come across the data types and you'll be able to know how to use them for that particular programming language. Yeah, so you can also have true or false. This refers to the Boolean. An example I gave was you're asking someone if they're married or not. They say yes or no. So that will give you a scenario of true or false. That's a Boolean. And then we can also have references. Now references are things like arrays, pointers. So we look at arrays later on. Okay, in this video, we've just said something about data types, and the important thing is for you to realize that there are different kinds of data types and you'll need to handle them, especially when you're taking input from users. If you're taking input from users, maybe it's a username, you need to control the kind of input that goes in there. That is why when you go to some kind of a website and you're filling a certain form and you try to type in your email, don't forget about the email, you try to type in actual words like ABCD in a place where you're supposed to put in your phone number, you'll see an error. That is due to data type. Maybe it was indicated that the kind of data type that goes in here are numbers only. And if you put anything else, that will give you an error. So in the next video, I want to go to the C++ documentation and just brush over some of the kinds of data types that we have there. So I'll see you in that video. Hey, and welcome back. So programming languages, some of them originated from others. So for example, we have some C-based languages. These are languages which are generally descendants of C, and they inherit some things from C. Languages like Java, C++, JavaScript, PHP, you'll find a lot of the syntax of these languages always have some commonalities, and that is because they are descendants of C, plus any others that I haven't mentioned here. They will have similarities in how the syntax is written and how certain things are handled in the languages. So in the last video, I told you that we are going to look at some data types that are somewhere here in C. Let me see. So it's just what I discussed in the last video. If you look at this, we have the character types. So they can be grouped into, generally can be grouped into this. So you have a character type that basically contains things such as single letters and special characters. And then you have numerical integers. So this will handle numbers. They can be whole numbers, negative numbers. And then you also have the floating point types. They will handle decimals. So if you have any kind of decimals, you would need to use one of the data types that fall under this. Then we have the Boolean type. Boolean type are essentially two values, yes or no, that is true or false. If a statement is true or it is false, the Boolean will only hold these two values, true or false. It's either true or false. So if I come down to this table, I can see I have character types. You can have the car. If you have just one character, you can declare it as a car or care. You can declare something like car. If it is to be just one single character, you can declare it as this. Then also depending on the bits and all this, but these are all in C, so you don't really have to worry about this if you'll be learning another programming language. So in integer, we have signed or unsigned. So in signed, it basically means that this has a plus or a minus. But in most cases, you'll just find this is not even put. You'll just declare your variables without really using this. So yeah, we have this short int. At some point here, you may declare a variable like a short int. You can have unsigned and signed. So unsigned don't have any sign before them. That is the plus or the minus. And then floating points, we have float or double. So if you want a float number, this is a number with a decimal. A double also a number that can handle decimals. Then you have long double. This one, if it is a large number, decimals. Then we have the Boolean type. Then we have this void. This is just non-existent. So this looks like some things that if you're interested in C, you'd come here. If you're not, you just ignore this. It doesn't really matter for you. You learn whatever data types are there in the language that you will be learning. But it's essential for you to know that different programming languages have certain things that are specific to them. Data types may also be specific to them. So one data type in one particular language may not be available in another programming language. So let's continue in the next video. Hello and welcome back. In this video, let's talk about variables. Now, variables are a reference to some kind of information. So what does that mean? For example, let's say you want to store passwords. So you can't store all the passwords that are put into your system. For example, you have a form. So you'll need to reference to all the passwords that will be input into your form. You can use something like password. You can declare a variable called password or just pass. So every time someone puts in their password, it can be accessed using our variable. So you're going to see this as an example. You remember there is an example I showed you about adding two numbers. We are going to use variables to represent those numbers, and then you'll see how we can access them. So a variable is a changeable value. So it is changeable. So you'll find that one person will put their password, then another person can also put their own password, and you'll be able to access them. Maybe using the ID of those particular people or using their username. So a variable is changeable. That's important to note because we also have constants. We are going to look at constants later on. It's important to note that variables are changeable and variables have identifiers. Now the identifier is the name of the variable. in the examples that I will be showing you, most of the time I'm going to be using identifiers such as X, Y, or AB, whereby you'll see X is equals to 1, or Y is equals to Z, or X is equals to Y. But in normal programming circumstances, make sure you give your variable identifiers names that match what they do. For example, if you're creating a system, a login system, you will want the username variable to just be something like username or user. And then password, you can give it password. So in this case, if you come back and take a look at your code, someday in future, you will be able to know what you are trying to do. So when you give your variable names, the variable names, give them something that describes what they do. If it is a variable for tax, make sure you call it tax so that you can know that that variable holds the value for tax. So the variable identifier is the name that you give to the variable. So in most cases, in every programming language, you'll have to declare the variable. Okay, in very strict programming languages like Java and C++, you will have to declare the variable before you can use it. In languages like JavaScript, you can use a variable. You can just start using a variable without declaring it, and there won't be any errors. But it also depends on how you declare it. When I will be looking at JavaScript, you'll see an example of these scenarios. So in this video, we have done an introduction to variables, and we've said that a variable is a memory placeholder. So I'll see you in the next video, and in the next video, let's just go to our C++ shell and see an example of this, and we can also do 1 or 2 examples in JavaScript using Scratchpad like we did last time. So see you in the next video. Hey, and welcome back. Now, when we were looking at data types, we said something about strongly typed and weakly typed programming languages. In a strongly typed language, when you declare a variable, you must declare the type as well. An example is C++ and Java. So in C++, if I'm to declare a variable called X, I have to say the type. If it is an integer, I will have to give it the type int X. And just like that, I have declared my variable. If I'm to declare a variable that is going to contain some kind of a sentence, I will just say string. I'll give it string and then sentence. So a string can be used to represent a sentence or a group of characters. In a weakly typed language, you don't have to declare the type of the variable. For example, JavaScript, and even in PHP, you don't have to declare the type. So if you're to declare a variable in JavaScript, maybe let me use the var keyword. I can say just var tax if it is for storing maybe some tax value, some tax rate, and you can also just declare without using the variable, but without using this var keyword, but you'll see about this in the JavaScript tutorial. So I can just do tax and I don't have to put the data type. You remember the data types that we had? Yes. So let me go to the C++ shell here, and let me say now for this one, we declare a variable of int X. Okay, in this case, let me declare them differently, and int y, and I can say int X is equals to 4, and then int y is equals to 3. So if I come here, I can use the variables. So this is what the variable is. It just stores the value of this, and you can access it anywhere in the computer, anywhere in your code. So if I say x plus y, it will give us the values of x plus y. So the variables x will be replaced with the value 4, and the variable y will be replaced by 3. So if I run this, you'll see it gives us 7 down here. So that's the good thing. When using variables, the variable will just store the value that it has been given. So you can change the value of this. If I take this one, for example, Control C, and then I copy down here, Control that, and then I change the value to 14. Now the value of x. So right now, the second time I'm using x, I do not have to redeclare this int x thing. So I can just remove this because the variable is already declared up here. Right now what I'm doing is assignment. We'll take a look at assignments later on, but the point is you've declared the variable and you can change its value. So I can change the value that comes out of this, and I won't need to change my code here. It will just now take the value, the new value of x. So if I run this, you see that the new value, the new output is 17. So variables are just placeholders of data. So they will reference some kind of a value, and you can change the value of a variable. So you can see, as you've seen, we've changed the value of x to 14. So in any programming language you will be learning, you will encounter how variables are dealt with in that particular programming language, but the concepts are just the same. You declare the variable, you give the variable an identifier, then maybe you can give the variable a value or not. So in this case, this will work because we've just declared the variable, we've not given it an initial value, and then down here, at least I have given it an initial value. So you'll encounter variables in whichever programming language you're learning. So in the next video, let me just do a quick example in the next video about JavaScript. So I will see you in that next video. Hi and welcome back. Now I want to do a demonstration in JavaScript. So as I said, you don't really have to follow along, but if you just want to feel good, you can do what I'm doing, and then you will feel the urge to learn more about this once you've actually done it in practice. So I want to do a JavaScript example with a variable, and I will do that using Scratchpad. So I said Scratchpad on Firefox, you just open with Shift F4. Now, in JavaScript, I can declare a variable var. Let me declare a variable var username. So this is a declaration. You can declare the variable and then give it a value later on. So for example, I can say, since I've declared the variable username, I can now give it a value of username is equals to bit. And when you're dealing with strings, data type of string, this is something that is like a word, a character that is not a number. You always enclose them in these quotations. If that's our username, we have declared it, we have initialized, at least given it one value, and then now let's say alert username. If I run this, it should give us the value of username, which is Pete. And then we can also do some kind of a mathematics thing. So let's say we do length, we declare length and we also declare. Now there's something you can do here. Instead of taking this variable and then redeclaring here, what I can do is so down here I'm supposed to declare width, because we want to calculate the area of what's it called, rectangle, length times width. So what we can do, instead of doing this, I can just take this and do it in the same line. So if I do that here, var length and width, this one declares two variables for me. And then, you know, this is a declaration of the variable. And of course, for me to use the variable, I have to give it some value. I have to give it something to hold. So in this case, I can say, I can give it a value of 10 and the width also of the width, let's say maybe 9. I could have done this in another line. So this is not a course about JavaScript. This is just introduction to programming and not about any particular language. So this is just a way for me to illustrate this thing about variables. So var length and width, then I can just come here and say length times, we are going to look at this these kinds of things later on when we come to operators. So for now, let's just use them. Okay, that's wrongly spelled. So you see what's good here. I can just come here and change the value of this, but I will not have to change my code down here. That's the good thing about variables. So if I run this, it gives us the product of these two. So if I come and change the value there, I can just run this and it will give us its value. So a variable just stores and references some kind of a value. So in real programming situation, you'll find that this variable is probably being input by a user, whereby you have a form and a user has to put in this value. So in that case, you can see how a variable will be useful, because you won't have to change anything within your code. You just change the value of the variable, and if you have a function that does something, then you just take the values that the user has input, and then the system will automatically fill in the value of those variables within here. I hope you're really understanding this thing about variables, because it's very important and you will encounter it a lot in programming. So I'll see you in the next video, where we are going to look at something that is close to variables called constants. See you in the next video. Hey, and welcome back. So let's say you have some values that should not be changed, and you want to use these values in your code. You can declare them as constants to protect them from being changed at any point in the code. An example is, let's say maybe something like VAT. If you know the VAT is fixed at a particular rate, you declare VAT as a constant, and then you give it the value. So in C++, you can do const, and then here is the data type. So in this case, it would be an integer if it is a flat rate of something like 16%, 8%. So most programming languages have constants, and you can declare a constant. So a constant is just like a variable, except it is not changeable. You cannot change the value of a constant once you declare it. Unless you go back to the constant itself, the declaration, you change its value right where it has been declared. So something like JavaScript doesn't have an exact equivalent of a constant, but there is something similar and close to that in ECMAScript 2015. That is JavaScript, the latest JavaScript. So there's something similar to that, but it doesn't have an equivalent of the constant the same way it is in things like C, C++, Java, and the .NET languages. So if I come back to the C++ shell, and let's say I declare this x as a constant, so you cannot change the value of a constant. So const will make this a constant. So this will give us an error, because down here I've also tried to change the value of this. So if it is a constant, its value cannot be changed. Let me run this. When I run this, you can see that it tells us that we cannot assign a read only. So when you create it as a constant, it becomes a read only. So if I was to remove this, everything should be able to work well. I was experiencing some issues with cpp.sh, so I came to id1.com to continue compiling and running my code online. I actually have a tool that does this. I use dev C++ for this, but I just want to do this online so that I can make it accessible to anyone who would like to run the same thing I'm running without installing anything. So the good thing about ID1 is that it supports different languages, but I just want C++, so I'll just go with this C++ 14, or I can go with C++ 5.1, doesn't matter. So I'll just paste in my code, and the code that we had in the other place was this, where we had confirmed that you cannot change the value of a variable, you cannot change the value of a constant once it has been declared and initialized. So we wanted to confirm that this is going to work after we removed the line of code which was here. So I'm going to run this, and after we run this, you'll see that our result is 7. So if you want to change the value of a constant, you have to change it within the declaration and the initialization right there. So if I want to edit this, I'll just click there and edit it once again. So if I want to change the value of this, I can change it there, and then I will run it. And you can see now it has changed again. So the point is, a constant once declared, the value cannot be changed, and that is what we have seen in C++. So I'll see you in the next video. Hi and welcome back. So in this video, let's have a look at operators. Operators enable you as a programmer to operate on different operands. So our operands can be a variable, constant, or whatever, or it can just be some number. So in this case, let's say it's a variable, and you can just do some kind of operation with it. So let's say you have x and y and you want to divide. You'll just say x divide by y, like that. And then you want to assign this to a value. You can say maybe z is equals. This is equals in programming is not the same is equals like in mathematics. So in mathematics, it means equals, meaning that something is equivalent to something. But in programming, this is assignment. So it takes the value which is this side and assigns it to the value which is here. That's why when we say x is equals to y, that means take the value of y and then put it in z, in x. So the new value of x becomes the value which is in y. So it's very important to note that x is equals to y is not necessarily equals to y is equals to x. This is true in mathematics, but in programming it is not. We're going to see comparison operators later on. But right now, just know that this is an assignment operation. So x is equals to y. That means assign the value of y to whatever is this side. If you say y is equals to 2, then this means assign 2 to y, to the variable y. Then we have these arithmetic operators. We have seen addition. Subtraction is also the same thing. Just if you want to add two things, you'll just put there whatever y plus z equals something there. Or if it is minus, it becomes now y minus. If it is multiplication, you use the asterisk. If it is division, you'll just use that. So it will be y divided by z. Then we have the modulo. Now what the modulus does is it gives you the remainder. So let's say we have 4 divided by 3. Is the percentage for this modulo 3. This one will give you an answer of 1, because 1 times 3 is 3, and then minus 1. So let's continue in the next video where we're going to see more about this one, because most of these are pretty easy to understand. If you want to divide, you use that. If you want to multiply, you use the asterisk. If you want to subtract, just use the minus. If you want to add, use the addition. So I'll see you in the next video where we are going to do an example with the modulo. Hi and welcome back. In the last video, we said something about the assignment operator and all these other arithmetic operators. So in this video, let's just elaborate a little more on the modulo. If I come here, let's say you're given something like 143 divide by, so this is in mathematics, divide by maybe 3. Now in mathematics, the way we used to do this before we used to use computers, we put it something like that, and then 1, 4, 3 used to come in here, and then 3, then we'd say 3 divided by 14, 3, no, we start from 1, 3 into 1, it doesn't go there, 3 into 14, it goes there 4 times, 3 into 14, 4, then it goes there 12, and then we have a remainder of 2, then we bring down 3, 3 goes there 7, which is 21, and then we have a remainder of 2. Now this is the remainder. Now this remainder will be the result when we do a modulo operation. So if we say 143, 143, and then modulo over 3, the result will now be 2. It gives you the remainder. So if you were to divide, it would give us 47 point whatever remains, that's 0.6, 2 over 3. Or if you were to get the answer as an integer, we'd get just 47. So let's do this and confirm this very division that we've done here inside of our IDE. So if I come here, let's say, let me remove the constant for now. X is equals to 143, and then int y 3. So x modulo, you use the percentage. Now x modulo y, then let's see what will be returned down here. So if you run that, you'll see that our answer is 2. So this is from the previous one. This one right here is from the previous. Our answer is that. So modulo gives you the remainder. Now let's see what happens if we do a plain old division. What result is it going to give us, since we have declared both of these as integers? So if we run that, you see, if you use it as an integer, it will ignore all the others and it will give you the integer. So let's say data type, I told you about float. So we make this a float and then we run it. You'll see it gives you back, including the decimal points. So you can see that this is very important. You have to know the data type that you want to be returned back to you. So if you want to see the decimal points, you have to use a float or a double. There's another one called a double. If you don't want the decimal points, you can just use an int and the integer part of the value will be returned to you. So in this video, we have done a demonstration of the modulo, which always returns the remainder. So an example where you can use a modulo is, let's say you want to find out if a number is an even or an odd number. You can use the modulo. Let's say you have x is your number and you want to find out if x is an even number or an odd number. If x modulo of 2, that means x divided by 2, the remainder is equals to 0, then that means this number is even. If it is odd, x divided by 2, the remainder will always be 1 if it is an odd number. If you take 7, divide by 2, that will be 6, remainder 1. If you take 1,000,000 something something and 1, you divide by 2, the remainder will always be 1. So you can use the modulo to say if a number is even or odd. So later on, we are going to look at conditionals, things like if, else, these conditional statements, and we're going to see how we can put this into practice. But that is just a rough view of where you can use the modulo. So I will see you in the next video. Hi and welcome back. So we have taken a look at all of this, including the assignment operator. Now let's go and look at something that we call compound operators. These are just combination of this with an equals. So if I come here, you'll see we have plus equals, minus equals. We also have times equals and divide equals, modulus equals. Let's say we have, let's start with the plus, x plus equals y. This is the same as saying x, this is the same as saying x is equals to x plus y. And then if it is x minus equals y, that's the same as saying x is equals to x minus y. And if it is times equals, that's the same as x is equals to x times y. And then if it is divide equals, that is the same as x is equals to x divide by y. And for the modulo, it's x is equals x modulo y. So let's go and see an example using plus. So if I come here to the browser, let's return this back to int y x, and then now we say that x plus equals y. So x plus equals, now let's output the value of x. If you output the value of x, we expect that it's going to be the value of x plus y. So let's just run this and see. And if we do output that, you see that the value of x is now the value of x, which is 143, plus the value of y, which is 3, and it gives us 146. So if I make this, let me divide. Now let me multiply. If I multiply x, so we expect to see something that ends with the 9. 3 times 3, 9, 3 times 4, 4 to 9. So let's run this. And it gives us 429. Let me see what happens if I do a modulo operation. So it gives us what we found in the previous video, which is 143 modulo of 3, which was 2. So that is all for this video. And in this video, we have looked at compound operations, whereby you can do this in a shortened way. You just do x plus equals y instead of writing this entire thing. So I'll see you in the next video, where we are going to see something that comes out of this kind of operation. See you then. Hey, and welcome back. In the last video, we saw something about compound operators, where we said x plus equals y can be expounded to be x is equals to x plus y. And now let's say x plus equals 1, or x plus equals, rather, x minus equals 1. Now how are we going to expound this? We are going to say x is equals to x plus 1, and also x is equals to x minus 1. And a short form of writing this, we can just say x plus, or we can say here x minus. So that covers this one, and this is covered by that. So x plus plus, this is the same as x plus 1. X minus minus, x minus 1, this is the same as x minus minus. So you'll see this a lot when it comes to loops, and we are going to look at loops later on, and you're going to see this is what I will be using. So this operator, the plus plus operator, it can come after or it can come before. So we also have plus plus x. So I'm going to show you an example of where these two can vary. And for this one also, you can have it come that. So minus minus x, or x minus minus. It said that this is where C++ came from. So it was a thought that now the original one was C, now the next one was C plus 1. So that's where C++ apparently the name comes from. And then we also have this one is not. Now the not, let's say not x. This one simply says not something. So if the value of this was supposed to be, so if x was true and then you say not true, it would go to false. So this is just not. You'll see this also a lot in lots of programming. So if you see this, it basically means not. Well, in certain programming languages, maybe it will be written like not, just like the word. But if you see this, in most C-based languages, these are languages that mostly originated from C. This is how not is written, and you'll also see these ones as well. So I hope you've understood these unary operators. The unary operators, they're called unary because they only operate on one operand. The others, you saw, they operate on two different operands. Here we have x, we have y. These are two different operands, x plus y, then x plus something else. So these are two operands. But the unary operators only operate on one, C plus plus. We only have one operand here, which is C. X plus plus x, only one operand. X plus plus, only one. Then minus minus x, only one. So I'll see you in the next video, where we are going to look at a few examples on this. See you then. Hi and welcome back. So in the last video we saw that we can say plus plus x or x plus plus. And in this video we're supposed to see what exactly is the difference between these two. So I'm here on the C++ tutorial, and you can see that we have this x is equals to 3, then y is equals to plus plus x, and then the value of x is 4 in this side, and y is equals to 4. And on this side, x is equals to 3, just the same thing, but now x is used as a suffix which comes after this. So x contains 4 in this case, yeah, and y contains 3. So you can see there's a difference. So let me come back here, and if I come back here, in this case you'll see that plus plus x, in this case this operation is used as a prefix. So the plus plus is prefixed to the x, and then in this case it is a suffix. It comes after x. What happens here is this: x is equals to 3. 3 is assigned to x, yes. And then now at this point the value of x is equals to 3. And when it comes down here, the value of x is increased by 1 to 4. The value of x is increased to 4 before it can be assigned to y. So if you see the prefix, the value of x is first of all increased to 4 before it is assigned. And once it has been increased to 4, it gets assigned to y. So in this case, x is equals to 3 and y is equals to the value of x, which has been increased by 1. And at this point, or actually at this point, the value of x is 4 and the value of y is 4. So I did this evaluation from this point, but now at this point here, the value of x is 4, not 3, it is 4. X has been increased by 1, it has become 4. And y is being given the new value of x. So here x is equals to 4 and y also equals 4. I hope you're understanding this up to this point. Somewhere after this, at this point here, maybe we are calling for the value of y and calling for the value of x. So at this particular point, after this line, x has been increased by 1, so it is 4. Y has been assigned the value of x, which is 4. So x is 4 and y is 4. But if we use this as a suffix, the value of x at this point, of course, is 3. And then y is given the value of x before x has been increased. So x goes to y, which is 3. So at this point, before we increase the value of x, we assign the current value of x, which is 3, to y. So y at this point becomes 3, and the value of x, of course, must be increased by 1, x plus plus. So x, of course, is increased by 1, and it becomes 4. So in most cases, just to avoid some logic errors in your program, it's always advisable to just use this. Or if you want to be extra careful, you can actually just use x plus equals 1, because this will always evaluate to x is equals to x plus 1. So at every point, this will always evaluate to that. So this must be evaluated first to get the value of this. So in this case, you have seen that if you use the plus plus as a suffix, the value is assigned before it has been increased. In this case, the value is increased first before it is assigned. So just play around with these, see some examples. You can even read more about this online. Just go online and read about unary operator, plus plus, or the minus minus. So you have seen how these two may vary, and these two can actually lead to logical errors in your program if you're expecting something else and the result turns out to be something else because you used the prefix instead of the suffix. So it all depends on what you will be trying to do. Anyway, I hope you understand the difference between these two. And with that, I will see you in the next video. Hi and welcome back. Now let's come back to our IDE and try something else. And in this case, I'm going to use the same example here. Let me remove this and that one as well. So if I declare int y and x, and then I give y is equals to 3, y int x, I've declared the two variables, y is equals to 3, and then we say x is equals to minus y. And then let's add another variable, call it z. Now this variable z, let's say z is equals to y minus minus. We want to see if there'll be a difference between the two values based on what we did with plus plus. So in plus plus we didn't do any example with it because I thought it was pretty comprehensible. With minus minus, let's see what happens. So the first cout will be, so cout is just an output in C. It outputs a value. So actually I don't really need the bracket for this one. So let's say cout x, and then I can also cout z. So I want to see the value, the difference between these two. So I hope this is not too confusing for you. I'm just giving out the output of this because I want to demonstrate the difference between these two, the suffix and the prefix. So I should probably add some space here. Let me just put a new line. So this will put the value of this in a new line and this in a new line. So the one at the top will be X, the one below will be Z. So let's run this and see if the value of this is going to be any different. So you can see these two have the same values. So for minus minus, we can see the values of the two are the same. And the reason why that is true is because at this point, the value of y has actually been polluted. So this was a very bad example that I did. So let me just do one at a time instead of doing two. Let me do one at a time. Let me just get rid of this X. If I can explain why these are the same, is because by the time the other one is being evaluated, its value, the value of y, is no longer 3. So let me just do this one at a time so that we can see that they are actually different. So x is equals to y, see out x, and then let's run that. And you can see at this point the value of x is 2, because at this point the value of y is 2. It subtracts 1 from 3 and makes it 2. So it is assigned the value of y once 1 has been removed from it. But if we do this, you'll see that it gives us a different answer. So you remember that at this point y is 3, and at this point y is going to be assigned to x before the value has been reduced. Note that the value of x at this particular point is 2. So if I run this, now as you can see, the value of x at this point, if we use the suffix, it becomes 3. So I hope you can see that if you decide to use any of this unary operator, you have to know that if it comes as a suffix, like in this case, this value is assigned first of all before this is changed. And if you use it in front here as a prefix, then the value, let's remove this and then put this, and if you use it as a suffix here, as a prefix I mean, then this full thing is evaluated first and then it is given to the value on this other end. I hope you have clearly understood this too. And if you do the same thing with plus plus, you're going to see the same results like what we did during the explanations, like what we came up with during the explanations. So I will see you in the next video. Hi and welcome back. So let's just be glad that the plus plus and the minus minus operators are behind us now. That means we can move on to a different kind of operators, and the next thing we are going to look at is the relational or the comparison operators. These are operators that are used to compare two values. So you can maybe say x is equal to, now this is equal to, not assignment. The other equals, which is this, will assign a value to this. But equal to has these two, so the two equal signs. That gives you equal to. Now the values of a relational operator will always evaluate to a Boolean value, and the Boolean values that we have are either true or false. So whatever result you get from your comparison, it will always evaluate to true or false. We also have the not equal to. You remember this only equals to not. This is the same as not. If you add that, it says not equal to. So we can say X is not equal to maybe Y. So let's say this was some kind of programming. You say if X is not equal to Y, then do the following statements. So this one is not equal to. So we have greater than. You can say X is greater than Y. Or we also have the less than. You can say Y is less than X. Then we have the greater or equal to. Now the greater or equal to, you can say X is greater or equal to Y. Of course, you also have Y is less or equal to X. So these are them. You can see what they are here. This will come in handy when you'll be doing things like comparison between two values, especially when you're doing conditional programming, when you use things like if this is true, do X, else do Y. So we are going to look at these ones, if and the if else kind of statements. We're going to look at them later on. So in this video, we've just done an overview of these relational operators, and how to use them will come in handy when you're doing conditional kind of programming. So I will see you in the next video where we'll continue from here. Hey, and welcome back. So let's look at logical operators. Now logical operators, this will help you to choose some kind of a logic. So for example, let's say you have a condition 1, and then you also have condition 2, and you want to do something if both conditions are fulfilled. So you can say if C1 and C2, then do the following. Now here's an example using the AND. You go to some kind of a cooking class, and the instructor comes up and asks a question. If you're a man and you can't cook, stand up. So for this to happen, for you to stand, this means that you must be a man and you can also cook. Because if you're a man but you can't cook, you will not stand up. But if the instructor comes in and says, if you're a man or you can cook, in this case, a man will stand. As long as you're a man, you're going to stand. And any person, whether it's a woman, a man, they will also stand. And then maybe you can also have, if you're not a man, stand. So in this case, all women will stand. So that's what a logical operation is. So after doing that analogy, we have this table here. So let's start with the not. This is very easy to understand. If not, then if you're not a man, that means any person who is not a man is going to stand. That means if this statement is true for you, whatever is requested of you here, you will do. Let's go to the AND. Now for the AND, this statement can only be true. Condition 1 and condition 2. This statement is only true if condition 1 is true and condition 2 is true. That will make this statement to be true. If condition 1 is true, are you a man? Condition 2 is true, can you cook? Then the full statement is true. Then you'll be able to stand up and do whatever is requested of you here. Then OR. For OR, if this one now is OR, in this case in C-based languages, OR is written with the two pipes, and the AND is written with this. But there are certain programming languages that you'll just write them AND or OR. So in this case, OR, condition 1, if condition 1 is true and condition 2 is true, then this full statement is true. If condition 1 is false but condition 2 is true, then this full statement is true. Like for example, let's say the instructor comes back and says, if you're a woman or you can cook, you stand up. So two people will stand. You are a woman is true, will stand if you're a woman, or you can cook will also stand up. Whoever they are, whether it's a man or a woman, both of them are going to stand up. So this full statement is going to be true as long as this statement will be true for you, whether you're a man. Let's say you're a man and you can cook. So in this case, if you're a woman or you can cook, stand up. That would mean that this man who can cook will stand up. Okay, they're not a woman, yes, but they can cook, so they'll stand up. This statement is true for them. So just have a look at this. A and B. Let me clean the screen. Now this statement, this one, is condition 1 and condition 2 for AND. So for AND, if condition 1 is condition A is true, you can see for AND it's pretty simple. This statement is only true if both statements are true. If any of the other statements is false, then this is false. That's for AND. Both statements must be true for the full statement to be true. Now for A and B, A or B, this is only true. This is only false if both statements are false. If one of them is true, then the full statement is true. If one of them is false and the other one is true, then the full statement is evaluated to true. If both of them are true, is true. If both of them are false, then the full statement is false, and whatever is down here will not be evaluated. So just have a look at this, and you can see this is pretty easy to understand. You just know that for the OR, both of them have got to be false for it to be false. For the AND, both of them have got to be true for the full statement to be true. So you're going to see this when we get to conditionals, things like if this statement is true, do Y. If this statement is false, do X. So I'll see you in the next video where we'll continue with our introduction to programming course. Hey, and welcome back. Now let's finish this section on operators by looking at operator precedence. Now the operator precedence basically defines what comes first, what comes next, what comes last. So let me just do a simple example here. X plus Y times Y, or maybe divide by Z minus 3. Now if you're given something like this, what's going to come first? So this is basically what operator precedence is all about. And don't forget, we also have things like this, in terms of this, even in terms of this, where you have to evaluate something and they are in one line and they have lots of different operators. So there are these links. This will take you to the MDN link, the MDN page on operator precedence. Now the good thing about this is whether you look at the operator precedence on JavaScript, you look at the operator precedence on Python, the operator precedence on C++, it's all the same. It doesn't matter. All the programming languages will just follow the same line of doing things. You won't find one where the plus comes after a minus. You know, every time there is a plus and a minus in the same line and there are no brackets that are separating them, then the plus will come first. And there's no programming language where you'll find that the times will follow the plus. You'll find that the times will be evaluated first before the plus. So let's go to these links and see. So here on the C++ documentation, here on tutorials, c++.com/doc/tutorial/operators. If you scroll all the way down, you're going to see the operator precedence. And here we have this scoping. This is a scoping for accessing different things in classes. So you can see we have the plus, the minus. These are at the very top. These are evaluated first. You can just use this to help you know how your program will be evaluated, or better off, you can always put whatever you want to be evaluated first in brackets, and then whatever is in the bracket will be evaluated first. So we have the unary prefix. So this is for absoluteness, maybe -1 or +1. That's what this is. Then let's come down here. So you'll see that these ones come at the very bottom. These ones are evaluated last before. So first of all, you do a logical AND or a logical OR in case you had some line that had different operators such as this. So that's basically what the precedence is. It evaluates one before another. So here you see these ones are in the same line. Divide, the modulo, and then below that we have the addition and the minus. So this one will come first, that one follows, and then that, and then plus, minus. So basically that's how it is. So if you come back here to, if you come to the MDN for JavaScript, let's look at, so here we have grouping. This one comes first, the bracketing. So just like any other place, the bracket will always be evaluated first. Then member access, this one is something that is in JavaScript, like maybe something is in a class, you want to say name.class or class.name, whichever you want to access. So you can just have a look at this, and you don't really have to memorize this, how it goes. You just need to know when you're writing your program. You can always go to the documentation of the actual programming language you're using, and you look at the operator precedence so that you can at least know which operation will be evaluated first, because you don't want to end up with logical errors, semantic errors, because you didn't align your operators the right way. So I will see you in the next video where we'll continue from here. Hi and welcome back. So in this section, I want us to start looking at something we call control flow. So control flow, this refers to how statements will be executed in a program. It basically determines which line is executed next and how the program flows from one to the other. So the idea of control flow statements is that you don't have to execute one line after the other, one line after the other, one line after the other. So we have something called procedural programming, whereby the statements are executed in procedures from top to bottom, but we still have control flow. So this control flow controls how the program is executed. For example, at some point, if it reaches a certain line, the control of the program might jump to somewhere else. It will be told jump to a certain section, or if the following is true, do this. Or we can have something like a loop. A loop is also a kind of control whereby as long as a certain condition is met, the loop continues to happen. So in control flow, we have things like conditional statements. We also have loops. We are going to take a look at loops later on. Loops. So we'll take a look at all of those in future, the different kind of loops that we have. So if I can clear the screen. So the first control flow that we are going to look at is the conditions. So in conditions, we have things like if, else, else if. So this is an example that is based on the C-based languages. In Python, the equivalent of this else if is something we call elif. And it's also available in other programming languages, but the idea is the same. So you'll come across this in nearly every programming language. So we are going to start by going through this one at a time. So in the next video, I want us to look at the if statement, and then after that we're going to look at the else, and then after that we look at else if. So I'll see you in the next video where we're going to see how this can be implemented. See you then. Hey, and welcome back. So in the last video we said something about control flow, and we also hinted on condition statements. Now in this video we want to look at the if statement. Now basically this is a statement that is only executed if whatever is in here. Okay, let me clear out everything. This is executed if the statement that is in here is true. If this statement is not true, then whatever is in here, the code that you have inside here will not be executed. So in a moment, we are going to see an example. So just a recap of the condition. The condition, as the name suggests, is a statement that is executed if a certain condition is met. So this is just a control of how a program is executed. So you can say, if this is true, do this, or else do something else. So we're going to see the else as well in the coming videos, and the else if in the coming videos. So for this one, let's start by looking at the if, and we want to see if x is equal to a certain number, then do something here. And we're also going to see if x is not equal to that number, if this statement is going to get executed. So I'm going to do an example with C++, just like we've done in the previous examples. So if I come back to id1.com, I want to do an example whereby x is equals to a certain number, and we'll say that if x is equals to that number, then do the statement that is within the if block. So I know in the past examples I've not explained exactly what this C++ code, what each line actually does. So let me write out the code of the if else and then of the if, and then we're going to at least go through this just to know what they are. So I'll start with the if. So I'll say if, first of all, let's declare an integer int x, and we can give it an initial value of maybe 10. So let's just say if x is equals to 10, and at this point I just want to, if x is equals to 10, I want to output something that says x is 10. Actually, because it is just one line, I can put it here. And then I want to say x is 10. So you can see, because this is one line, I can put it here without using the curly braces. Or I can put it down here and add the curly braces. So the purpose of an if statement is to make sure that a certain condition is met, and then whatever lines you have of code will be in here. So this is just a very simple example, but you may want to use this for a more complex example. So this is the structure of a C++ program. So this one up here, the one that has this hash pound, what this does is it includes a file for the C++ preprocessor. So if you go to compile this is a directive to the compiler to include this file. So any time you see this hash in front of anything, this is something that is an instruction to something called a preprocessor, which is inside of a compiler. So that will do the directive that it is given. We also have another one that is called define, which can be used for defining something like a constant. But just so you know, this one will include that for the preprocessor, and the compiler will add this file. And then using namespace std, this one, what it does, this one basically enables me to avoid writing something like if I come down here and I was to do a cout, I would have to write std like that, and who wants to write this all the time? So for me to avoid writing this all the time, I just say up here, you'd say using namespace std to avoid me from using this. So when you start learning C++, you'll see that in the first examples, you're probably going to come across them. You're going to come across examples that have the cout like this and the cin like this and other commands like this. So the int main, this is a function. This is essentially a full function, and we're going to look at functions later on. So here, int main, this is a function. The main function that is usually run in a C++ program is the main function. So you can write your functions everywhere, but in the end, you're going to call them in the int main. This is the main function. This is a function that is actually run and where all the action happens, where everything is brought together, and whatever the program is supposed to do will be done inside the main function. So coming back to our if statement, so this is an if block, and we can say if x is 10, then cout x is 10. Then I can also copy this and just paste it down here. Oh, I haven't said this one. This one is a comment. So a comment is just a way for you to know what's going on. It doesn't do anything, it just helps you comment. So maybe if I want to add another comment here, I can say my first if statement. So the good thing about a comment is if you come back to your code, maybe in future you will know what you were trying to do, because if you look at your code later on, most of the times you'll just get confused even if you're the one who wrote it. So it's always good to write comments, and we're going to look at something a bit more about comments later on. So in this case, we've said if x is equals to 10, and please note that we're using the double equal sign, which equalizes, what is it called, a comparison. So this is a comparison. If I use the one equals, this is an assignment. So let's say here x is equals to 20, x is equals to 30, x is 10. So we are going to see which of this is going to get run. So if I run this, so you can see we have a compilation error, and this is due to, this is a syntax error. So we're also going to look at errors later on, and a syntax error is due to something that is missing here, that, and that. So the purpose of this is to end the line, to terminate this line so that the next line can begin. So if you run this one more time, you'll see that the result you're given is x is 10. So if I come here and I change x to 30 and then I run this, oh, actually, let me change this one. X is 30. And then we see if it's going to run x, this condition is true or this one is true. So if we run that, you'll see the result that we're given is x is 30. So the if statement will evaluate the thing that you put in here, and then it will run the code that is within the if block. If this statement is false, then the entire thing will get skipped and this code will not get run. So I'll see you in the next video where we're going to continue with the if else, and we're going to see how we can do this without using two if statements. See you then. Hi and welcome back. So in the last video we looked at the if statement. We even looked at an example. So in this video, let's look at an if-else statement. If this statement is true, then this will be done. However, if the statement here is not true, it is false, then the statement here will get run. The code which is inside here will get run. So this is good for something that we call defensive programming. So this is whereby at least you try to anticipate if there will be any errors or if there will be certain things that are unexpected. You can do something that is expected to happen here, and then if this doesn't happen, then you can be defensive by trying to make sure that at least whatever issue arises from here, you capture it and handle it within the else statement. In brief, the if-else statement is a way for you to anticipate. If something is not going to happen here, at least make sure you capture it and handle it here. So in this example, let's do this by seeing if a number is even or odd. So when we were looking at the modulo operator, we said that one of the ways that you can tell if a number is even or odd is by using the modulo. So in this example, let's try and use that similar thought in seeing if a number is odd or even. I'll come back here and let me just remove everything except for our int x. Let's say here, this is a number and we just want to see if this number is odd or even. So we're going to say if, let's use the modulo and x modular, and we say that x modulus of 2, if the answer is equivalent to 0, then this number is even. Then we are going to see out. See out is just an output. So we are going to output this statement. This is an even number. And then else, if that is not true, Control C, Control V, this is an odd. This is an even number. So let's remember to add that and also add that. And if we run this, we want to see if this number is an odd number. If it is odd, we are going to get that it is an odd number. So if I run this, so you can see it tells us that this is an odd number. I know you do understand this because we looked at this in the modulo operator, and we say that a modulo will give us a remainder. If a number is divided by 2 and the remainder is 0, therefore that number is an even number. If that remainder is 1, then that number is an odd number. So in this case, if you divide this by 2, there will be a remainder of 1, which makes this an odd number. So you can see here that you can use the modulo to handle that. So if we make this 0 and then we run it, you'll see that now it's an even number. So I hope you do understand the use case of the if and the else statement. So the statement in here must evaluate to true. If this statement is true, then this is getting run. However, if the statement here is false, if this is false, then this is going to get run. And if this one is false, what are you going to do? So that's what we're going to handle in the next video. So I'll see you in the next video. Hi and welcome back. So in the last video we looked at the if-else statement, whereby if something is true, do whatever is there. However, if it is false, do whatever is in the else statement. So in this video, let's look at the else if else. Well, you'll find this one is called the if-then statement. So you'll find this in most programming. It's called the if-then, but it will be implemented as if else. So if I can explain how this one works, the if statement will check if the condition here is true, and if the condition is true, whatever is in here will get run. However, if this is not true, then let's check another condition and see if whatever condition is in here is true. Then we'll do this one. And you can have multiples of this. You can have another else if down here to check other things before the else. So just in case all the above statements are not true, we are going to do whatever is in the else statement. So if you try the if and the if statement is not true, you try the else if, not true, then you have another else if, not true, then we are going to do the else just to have something as a preventive measure. So I want us to look at an example, and I want us to do something like somewhat a real life example. And the example I want us to look at is, let's say that you run an online liquor store where people come to buy alcohol, and you want to make sure that you're selling alcohol to people of age. So maybe you'll have a variable where they input the age, and if their age is beyond a certain limit, you will tell them, you'll give them a certain message, okay, go to the next one. If their age is below a certain number, you'll tell them, do something else. That is the example that I want us to look at. And in the next video, that's what we are going to do. We are going to do an example whereby we use an age. Depending on the value of the age, we output a different thing. So I will see you in that next video. Hi and welcome back. So in the last video, we say that we are going to see an example, and I have taken some time to write this so that we don't have to do it again in this video. Basically, what this does is we have an integer of age, and I've just decided to give it a value down here. I could also have just taken this and put it here, but I wanted to do it down here. So what this one does is it checks if the age is less than 18, that will be done. Else, if the age is greater or equal to 18, then this is what will happen. Else, if the age is greater or equal to 106 and the age is less or equal to 160, then this is what will be done. And then if none of this is true, maybe the age is greater than 160, this is what will be said. This is what will be output. So the example is that this is a liquor store, an online liquor store, and maybe you're taking this value from the user. They put in their age, and then depending on the age, you can give them access to your site. So if they're less than 18, for example, in a real scenario, if they're less than 18, you'd probably not give them access to your website, but we're not going to do that code in here. We're just going to show this message. If their age is greater than 18, maybe in a real liquor store, online liquor store, would be to let them into the website and have them buy whatever they want to buy. And if their age is between 160 and 106, you probably think they're lying. Maybe someone is playing around, just playing around. So you'd probably also ask them for their real age. And the reason I put the and here was because I wanted to at least show one example which has this else being done. At some point, this one can also be executed if none of this is executed. So the if then statement, which is the if else, how it works is that is checked, then that is checked, and if this one is true, if the first if is true, then of course none of these others will be executed. If this one is not true, this one will be checked and executed. If none of this is true, then the else will get executed. So I want to copy this code and let's just run it and see all of this. So if I come back to ID 1 and I come into my int main, this is where my main code should be. So I will just remove that and then do that. So here we have an integer, age 19. If age is less than 18, this one will be done. Is greater or equal to 18, they're allowed into the website. Else if age is greater or equal to 106 but less than 160, then this one will be done. And then the final part, if none of the above is true, then we're going to do this. So if I run this at this point, I have just made the value of age to be 19. So that means that we are going to expect the statement which says if age is greater than 18 to get run. Although this is not a very good way for me to have done it. I should also have added if it is less than this one, but I know since it is greater than 18, this one will get run. Let's just see what happens. So if I run this, I don't know why I keep forgetting this thing. There, and then there. Then we run it again. So you can see that it gives us you're welcome to the store. If I make it, let's make it 10. The age is 10. If the age is 10, we expect that the one that is going to get run is you're too young. So let's run this. And if we run that, it shows us that you're too young. Welcome back. Come back on your 18th birthday. So what if we say that, what if we say it's 200? If we say it's 200, it's not going to fulfill any of this. It's not going to be in here, not there, not there. So if you run this, okay, you can see why I was saying that I should have added an and along with this. So let's just add that here, at least to help. And Control C, Control V. So if the age is greater or equal to 18 and less than 106, at least this will cover this point. And then all the ages that come after 106 will be covered by this one. Then let's run that. So you can see once we add this check, at least it tells us that it asks the users for their real age. which is in the else statement. So what happened when I didn't have this was something that it can be a logical or a semantic error. So in programming, this was true, yes. In fact, it gave us a result, but it gave us the result that we were not expecting. So this can fall under logical, runtime, or semantic error. And at some point, you're going to look at errors just to explain what kind of errors you can expect in your programming. So you need to know that something can work well. Yeah, it will get executed, you'll get an output, but it won't necessarily be what you expect. So it's always good to note that when you're doing your conditionals. So let's continue in the next video. And if you have any questions, feel free to send me a message. Feel free to reach out to me and let me know about any questions that you have. So I will see you in the next video. So I've decided, let's do another example about the if-then. And the example we want to do is a very common one. So let's say you have points and then there's a pass mark. So you want to give people a certain kind of a grade or some kind of a remark. I already have the code here. We have this variable points. So if someone gets between 0 and 40, they have failed. If someone gets between 40 and 60, they have passed. If they get between 60 and 80, then they get a good remark. If they get between 80 and 100, that's extremely good. Otherwise, it is invalid. So let me copy this and run it and see what to expect. And I will start from here and then up to there, delete this bit. So let me add that. So if I run this, you'll see it gives us a result of passed, which is good because they have points of 55. Let's say we give it 155. Let's see what will happen. If we run that, it will tell us that we have invalid points. And if we put negative 99, let's see what's going to happen. If we run this, you'll see it also gives us invalid points. If I hadn't put this on, then we would have an error with this one. It would give us a result, but there would be an error. If I remove this bit, let me just show you by example, and then we have a point of negative 99, and I try to run this, you're going to see it gives us a value failed. So if I run this, it gives us a value failed because we have said that less than 40. What if there's another way we can do this without having to put that other one here? So with the if statements, we can nest them. And what we can do, we can say that we have an if within an if. So we want to protect this if. So let's say if we want to make sure that if x is greater than 0, actually let's make it greater or equal to 0. Greater or equal to 0, that is when this other will be run. That is when this entire code, the code that we've just added, will be run. So it ends here. There. So it ends here. So what this one says is if x is greater than 0 is greater or equal to 0, that is when the code that is in here will get run. So let's just run this with our -99 and see what is going to happen. So if I run this, compilation error function, I'm so used to x, this is points, not x, points. Then we run it again. So you see what happens here. This is false, but there is no way for it to know what to do. The if that is outside, I hope you're getting this. What happens is this if is false, but there is no else to handle what will happen. So this is where what you are talking about, which is defensive programming, comes in. So you add an else to make sure that there is a way for the false statement to be handled. So here we can say cout, Control V, points is less than 0. So if I run this again, it will give us this result. So you can see that this is very good for defensive programming, and defensive programming is nice where you expect users to give you a value. So if this was getting added by some user and they made a mistake, then you can handle that. You saw in the other two examples, there was no way for that to get handled. There was no output. So it's always very important to give people output. If there's some kind of an error, you give them an output. So I hope these two examples have helped you understand these conditional statements. So in the next part, we're going to start looking at loops, and so I will see you in those next videos. Hey, and welcome back. From this point, we are going to look at loops. Loops is part of the control flow that we were talking about, which shows or tells a program how a statement is executed. So in the last part, we were looking at conditions whereby if something is true, do something else. In this part, we are starting with loops. And in loops, what happens is, if a certain condition is true, if a condition is true, then you must continue doing a certain statement for as long as that condition is true. Let's say you want to write a certain number 10 times. You can use loops to achieve that. Or another example, you want to write the numbers 1 to 100. You can use loops to achieve that. So a loop basically has a condition. So the loop begins here, and as long as this condition is true, then this loop will continue to get executed. So as long as this is true, it gets executed. It just continues until it reaches a point when it becomes false. If it becomes false, then we will jump out of the loop and the loop will end. So when you jump out the loop, you can continue with the code, or you can do whatever you decide when the loop becomes false. So what are some examples of loops that we have? So we have the while loop, we have the do while, and the for loop. So we are going to have a look at each of these with examples. So right now, just know we have the while loop. While something is true, do a certain statements until they become false, then you jump outside of the loop. So a do while loop, you do something, do whatever it is you're doing in there while the statement is true. So as long as the statement is true, it will go back to continue doing whatever is here. Then the for loop, for if something is true, if the statement in here are true, then continue doing something within here. So you can go back to the section I told you about control flow, and you can have a look at the section on loops if you want to understand more about how loops work in programming. However, in the next video, we're going to do an example with the while loop. So I will see you in the next video where we're going to look at the while loop.